So welcome everyone. I'm DB. I've already put my slides up online, so if you want to check out the meetup event, there's a link to where you can download and view the slides if you want to cheat and run ahead of this presentation. This is me. I'm a senior front-end developer at Impraise. I have a background in back-end dev as well. I've done a lot of different presentations at different conferences, so I like speaking at meetups and in other technical settings. And I'm here on behalf of my company Impraise. We're hiring. We're desperately trying to find more front-end developers. So if you're interested in the job or you're interested in what I have to say today, and you think you might want to work on it, let me know. So the basic problem that we were trying to solve when building this project was that our website sends a lot of email. And the way that our website works is we have a very spiky load on our emails. So Impraise is a system that helps companies manage performance reviews. And typically we want to send out reminders for everyone in the company to say, hey, you've got 48 hours left to submit your review. Hey, you've got 24 hours left. You've got 4 hours left. Go to the website and actually do your review, please. So what that means is every so often we go from 0 emails sent to a couple hundred or 1,000 emails sent as quickly as possible because these are notifications and they are time sensitive. While we don't actually do the email sending ourselves, we do need to render the HTML that goes into each of these emails so that the people receiving the email sees their name and the information related to their review. And it got to the point that our backend servers were getting bogged down by so much HTML and text that they needed to render for these emails. So what was a good solution to having a spiky workload? We decided to check out AWS Lambda and see how we could harness the power of Lambda to scale up and down very, very seamlessly. The next question was, what do we actually run on Lambda? And the front-end team at our company decided, why don't we check out React? Why don't we try running React on the server side in order to render the HTML for these emails? So the nice thing about that was it's a familiar technology. We're already using it in Impraise. It's a familiar use case because basically rendering HTML is what front-end development frameworks are all about. So it's already well-tuned for this use case. And of course, because it's JavaScript, we have access to the entire NPM ecosystem, and we could pull down lots of different tools that would help us out. Also, as was mentioned earlier, this is like the hipsterest of hipster technology, so we figured, why not see just how far we can push the envelope? So we came up with this project that we're calling React Mail Merge. And it is open source. You can go on GitHub right now, check out the project, clone it, play around with it, and so on. Some people might be thinking, so what's with the name? Well, any of you who were around in the bad old days before email got to be super popular, there was a process in Microsoft Word called a mail merge where you'd link up your address book with a form template in Microsoft Word that had forms for like a first name and an address and so on, and it would link these two together and create for you a couple hundred different copies of a letter that's almost the same but has information from the address book for each person. So it's sort of like what we're trying to do here. This project is not actually delivering emails, it's just putting together the HTML to do so. Plus, it's way retro, and we've decided that everything old is apparently new again, because tech keeps on reinventing the wheel over and over and over. But that's a side conversation. Anyway, so how does this project actually work? First of all, it's more of a set of guidelines than a reusable framework. We don't really have a project that you can plug your own code into. But the way that the code as we've written it so far works is we have one Lambda function per email template. Now this means that your email templates can be as flexible or as inflexible as you want them to be. So for example, we have an email template for inviting users to our platform. We have an email template for letting them know that they've joined a group and so on. But we also have one email template for all of the different reminders that we send, whether it's a 4-hour reminder or a 24-hour or a 48-hour or 1-week reminder or whatever. We all use the same template for that. So you can be as flexible as you want. We have an API exposed so that you can invoke this template with structured data. Mail merge does data validation to make sure that the data that's being passed is exactly what's needed to render the template. And you're not missing anything important like, the name of the person who we're sending the email to. Then it renders the email templates, both HTML and text. And you can either pass it a single set of data for a single person, or you can pass an array of data for every single user that needs to receive one of these emails. Then it takes the results of that rendering and passes it along to your mail delivery service. We happen to use a company called Postmark, but you could customize this to use whatever mail delivery service you want. And it gets any errors that might occur from the process of sending the emails from the mail delivery service and logs them and returns them to our backend that's calling mail merge as well. So there were a couple of benefits that we wanted to get out of this project, like being able to deal with spiky workloads. But there were also a couple of unexpected benefits that we found along the way. And briefly, those are using Storybook for mail preview, finding out that fixing the email copy using this project was surprisingly simple, using JSON schema as documentation for our backend developers, having robust localization and internationalization support, and also being able to do continuous deployment via our CI system. So what all those means? First, let's start with Storybook. I don't know if any of you are familiar with this really handy project called Storybook, but basically what it allows you to do is to take a component that you've written or a section of your code and display it in a way that's very friendly to see and easy to modify. So in this case, we've set up Storybook with a bunch of our different email templates, and we've added in some basic information that you can use to render the information as well. So we're using this plugin called Storybook Knobs. So you can put in the base URL that you want the links to go to, the username that you want to show up in that email, and a couple of other pieces of information as well. It's really easy to change. It's really easy to instantly type in a different name, type in a different group name, and so on, and see how your email is going to look with that new information. Now, as an aside, HTML email is awful. And just because something displays properly in the latest version of Google Chrome does not mean that it's going to display properly in an ancient version of Microsoft Outlook. So you have to do more validation than just checking in Storybook, but this is a good start. Another unexpected benefit that we found was easy copy edits. You're all familiar with React. You're all familiar with the JSX syntax. Essentially, it looks more or less like HTML. And we found that people at our company who were not developers but already knew HTML were able to understand what was going on in our email templates and to very easily make copy changes. So if we found that a word was misspelled or there was some phrasing that was a little bit awkward or something like that, the product managers and product owners didn't have to wait for the developers to get started on this. They could actually make their own pull requests to the repository, and this happened multiple times, which was really cool because it meant that the developers could focus on the more difficult, deeper problems, and the people who wanted to focus more on exactly how the emails were written and how they were displayed could focus on that very easily as well. We also used JSON schema to validate the data coming in to our Lambda function. So this serves two purposes. One, it makes sure that the templates that we're using receive the data that they need in order to render properly. For example, if you have a reminder email that is supposed to remind someone about an upcoming event, but the data that gets sent to React Mail Merge doesn't have any information about that event, you're not going to be able to generate an email that's actually meaningful to send off to the user. So we use the schema validation to make sure that whatever the backend is passing is actually meaningful and has the correct structure. But in addition, we found an extra unexpected benefit here, which is that the people who were writing the backend of our software, the people who needed to actually integrate with AWS Lambda, were able to use these schema files as a form of living documentation. So they could simply read the JSON schema file and see exactly which information the Lambda function was requiring and the format that it was requiring it in. JSON schema is a pretty readable standard, and you can learn more about it on the website. We were using a library called AJV to handle the validation. It also does really nice error messages, which is important. We also do localization in our emails because we need to be able to display information such as dates and times in a way that is robust and works for lots of different users. And if you don't think that this is important, then you've probably never had to deal with user time zones before. We have users all over the world, and all of them expect to see notifications in their native locale. It doesn't help someone who's living in Europe to see the date and time that an event is closing if that time is in the US time zones, or vice versa. Everyone wants to see information in their own local time zone. So that's why it's important to be able to have information about your time zone. Fortunately, there's a really handy library called format.js, which handles localization in React really smoothly. I was shocked to find that it was by Yahoo. I didn't know that Yahoo was still doing cool stuff these days, but apparently they are. And lastly, we're doing continuous deployment as well, because Lambda is very easy to deploy new versions of functions onto and very easy to test as well by having lots of different functions deployed in staging services as well. We're using a system called Apex to manage how we upload and deploy all of our functions. I'll be honest, I don't know all that much about how Apex works. I'm a developer, I'm not so much focused on the DevOps side. But it's something that was very easy for our DevOps people to set up, and we have our system running on CI. Specifically, we use Circle CI, and every time a commit is merged to master, it just redeploys all of our Lambda functions, and it works beautifully. You can also run automated tests to make sure that the code that you're writing is safe and isn't going to break things, and we have very high test coverage. Actually, on our project, we have 100% test coverage at the moment. Now, it's not all roses. We did run into a couple of unexpected problems, and I'll go over them briefly. First of all, we discovered that backwards incompatible changes are painful. As I just mentioned, we do continuous deployment for all of our Lambda functions. So what that means is, as soon as something is merged to master, it's out on production. There's not really any delay. So if we want to change the schema that we mentioned, this JSON schema that I talked about earlier, let's say we want to change the name of one of the parameters. Well, we did that a couple of weeks after launch, and then shortly discovered that all of our emails were failing. And that happened because we hadn't yet made the change to the backend that was calling our Lambda functions. So it was passing information in the old format, whereas Lambda was immediately expecting information in the new format, and so it was just throwing validation errors. So we reverted that change very quickly, and we've learned that now all changes need to be backwards compatible, at least until the backend is modified to fit with the new structure of the data as well. We also unexpectedly discovered problems in our database, problems with the data that we held in Impraise. So for example, every single one of our emails has a big highlighted call to action button. So it might be something like log in and accept your invitation, or go and submit your review to this person. We had our emails set up so that if you pass an optional invitation token parameter for each user, that was supposed to indicate that the user hasn't actually claimed their account on Impraise yet. And therefore, the call to action should say, register and submit your review. Otherwise, it should just say, submit your review. Well, we had a couple of customers contact us and ask us why they were being asked to register for their Impraise account that they'd had for a couple of months now. It turned out that the code in our backend wasn't properly deleting the invitation token, and the backend was just, merrily sending that information along to Lambda, which meant that our emails were doing exactly what they were coded to do. They were sending along the information that said, you need to register. So having this robust data validation helped us to discover problems that we didn't think we had in a very unexpected place, and we were able to solve them pretty quickly. This is not so much a problem, just sort of a lack of time issue. We haven't actually gathered performance metrics. Now, I said right at the beginning of the talk that one of the reasons why we wanted to do this is because we had a very spiky, very heavy workload. I'll be honest, I don't actually know what our workload was like, and I don't actually know how much it's improved. I presume that it has, but this is one of the things that we're looking for help on this. We know that we want to move in this direction. We know that we want to gather performance metrics and make sure that our servers and our services are running smoothly. It's just not something that we've gotten to yet. There's another problem that we've been having where we have unexpected timeouts on AWS Lambda. Most of our functions go perfectly smoothly, and all of our emails are getting sent out, but we've discovered that some of these Lambda functions, after the email gets sent out, after we send it over to Postmark, our email delivery service, just kind of hangs out, just kind of waits on Lambda until the timeout happens. Doesn't exit, just waits until Lambda kills the process. We don't know why. We're hoping that we can figure out why that's happening so that we can cut off these processes earlier, because of course, every millisecond that we spend on Lambda costs a little bit more money. So it would be really nice to figure out what's causing these timeouts. So as you can imagine, we could use your help. As I said, this is an open source project. It's MIT licensed, so you're welcome to check out the code and to use it for yourself personally, use it for your company. The way that we made this project open is we started out writing a private repository with all of our actual emails, and we stripped out all of the private proprietary information and logos and such and made this repository, which is open. So as a result, this repository is fairly minimal right now. We have 2 example emails that you can check out. They are based on real emails that we use at Impraise, but of course, they don't use our logos or anything like that. We would love if you could check out this project, try it out, maybe write a couple of more example email templates. We'd love to see people using different email delivery services. As I said, we're using a service called Postmark, but it probably makes sense to write a service that works with Amazon SES, which is their email delivery service. Maybe people use Mailgun, maybe people use something else. If you use something, give it a try and let us know how it works. We would love some better documentation as well. The documentation that we have is sort of copied over from our internal project and is really meant for internal use, but we would love to have more robust documentation about this is what the project is, this is why it works, this is how it works, this is how you can adapt it for your own project and your own use case. As I mentioned before, we're using Circle CI for our continuous integration system. But for this React Mail Merge project, I've also set up Travis CI just to handle things like running the tests and deploying the latest version of Storybook to our GitHub pages so that you can check out how it looks online. So we actually have both files in the repository. We have our travisci.yaml and we have our circleci.yaml. You can take a look at both of them. It would be great to have some documentation explaining what each one is for and how they work. And generally, just kick the tires and let us know if it's helpful. We built this project for ourselves, but it would be great if other people got some benefit out of it as well. So that's basically what I've got. The repository is online, as I've said. My name is DB. I work for Impraise. The slides for this presentation are also online. There's a link in the meetup description as well, and I'm happy to take questions if there are any.